Hello, everyone. Welcome to section 13.2. In the previous section, we talked about finding limits graphically, but in this section, we're going to be talking about finding limits algebraically without graphs. So to do that, we're going to gather some tools that will help us find limits algebraically. The first set of tools that we're going to need are some special common limits. So the first special limit that we're going to be using is if you have the limit as x goes to a of c, where c is like some number, some constant, like 3, for example, that limit is just going to equal whatever that number is, right? That kind of makes sense. Kind of similarly, if you have the limit as x goes to a of just x, well, that limit as x goes to a of x is just going to be a. Okay. Another special limit that we're going to be using is if you have the limit as x goes to a of x to the n, that's going to be equal to a to the n. So this is where n is a positive integer. And then similarly, if you have the limit as x approaches a of the nth root of x, that's going to be the nth root of a. Again, where n is a positive integer. And a is greater than 0. So we can actually put it underneath that nth root, and it makes sense. Okay, so these are some of the special limits that we're going to be using. What we're going to do is we're going to use these special limits and some limit laws that I'm about to talk about. And we're going to use these two things to sort of break down more complicated limits into smaller pieces. And then we'll be able to know what those smaller pieces do. So the special limits are the smaller pieces, and the limit laws are how we're going to break them down. So let's go ahead and talk about those limit laws. So if we're going to let c be a number, and suppose the limit as x goes to a of f of x, and the limit as x goes to a of g of x, let's suppose that these both exist, because limits don't always exist. Then here are the limit laws. There are 7 of them, but let's go ahead and just crank through them. First, the limit as x goes to a of f of x plus g of x, that's going to be equal to, so the sum of the two functions, the limit of the sum is going to be the sum of the limits. Limit of f of x, a limit as x goes to a of f of x plus the limit as x goes to a of g of x. That kind of makes sense, right? That seems like that would happen. Kind of along the same lines, just instead with subtraction, if you have the limit as x goes to a of f of x minus g of x, that's going to be equal to the limit as x goes to a of f of x minus the limit as x goes to a of g of x. Cool. The third limit law is if you have the limit as x goes to a of some number c times f of x, your function, what you can do is you can pull that c out in front of the limit. So this is equal to c times the limit as x goes to a of f of x. this one's pretty nifty. Okay. Number 4 is that if you have the limit as x goes to a of f of x times g of x, that's going to be equal to the limit as x goes to a of f of x times the limit as x goes to a of g of x. Similarly, if we have the limit as x goes to a of f of x over g of x, that's going to be equal to, you guessed it, the limit as x goes to a of f of x over the limit as x goes to a of g of x. And that's as long as the limit as x goes to a of g of x is not 0, right? We don't want to divide by 0. Okay, 2 more to go. Number 6 says that if you have the limit as x goes to a of f of x all raised to the nth power, that's going to be the same thing as the limit as x goes to a of f of x, all of that raised to the nth power. And this is where n is a positive integer. Lastly, number 7 says that if you have the limit as x goes to a, the nth root of f of x, and that's going to be equal to the nth root of the limit as x goes to a of f of x. And this is where n is a positive integer. And if n is even, the limit as x approaches a of f of x is greater than or equal to 0. Okay, so these are our 7 limit laws that we will be using. There's so many of them. Sometimes it can be hard to really grasp how we can use all these tools, and there's so many of them. So let's go ahead and take a look at something in action. Let's say we wanted to find the limit. And let's do the limit as x goes to 3 of 2x squared minus 3x plus, actually, let's do plus 4. Okay, so pretty straightforward quadratic. What we can do is we can use the first and second laws and split this limit up over the addition and subtraction. So this becomes the limit as x approaches 3 of 2x squared minus the limit as x approaches 3x plus the limit as x approaches 3 of 4. So this was using laws 1 and 2. Okay, now we can pull some constants out of limits. So we got limit as x approaches 3 of 2x squared, so we can pull that 2 out in front. So we have 2 times the limit as x approaches 3 of x squared minus, and then we can pull that 3 out of the second limit. So 3 limit as x approaches 3 of x, and then plus the limit as x approaches 3 of 4. So this was using law 3. And now for that first limit, we can use law 6 on it. Because we've got an x squared, we can kind of think about moving that squared out of the limit. So we have 2 times the limit as x approaches 3 of x, and then that whole limit is squared now, minus 3 times the limit as x approaches 3 of x plus the limit as x approaches 3 of 4. So that was using law 6. Okay. Now, at this step, we can use our special limits. We've got 2 times the limit as x approaches 3 of x. We know from our special limits that's going to be 3. Minus 3 times the limit as x approaches 3 of x. Again, that'll be 3. Plus, and then the limit is x approaches 3 of 4. That's just going to be 4. So this is using special limits. Okay, and I think we can do some simplifying to this. I think eventually we get something like, let's see, 2 times 9, so that's going to be 18, minus 9 plus 4. I think this eventually works out to be 13. That's the limit. Okay, but real quick, let's note something interesting. Note that if we take our original polynomial, the 2x squared minus 3x plus 4, and instead of doing all this limit nonsense to it, if we just plugged 3 into the polynomial, so 3 squared minus 3 times 3 plus 4, if you plug these in and you use some simplifying, so I think this becomes like, let's see, 3 times 3 is 9, so it'd be 18 minus 9 plus 4. Ah, it's 13 again. This is interesting. It turns out that this holds in general. So fact, if f of x is a polynomial or rational function and a, some number a, is in the domain of f of x, then the limit as x approaches that number a of f of x is going to be equal to f of a. So what this is saying is that if you have a polynomial or a rational function and you have some point in this domain and you want to know what the limit is of that function as we get close to that point, all you got to do is plug that point in. So for example, let's say we wanted to find the limit. Let's say we want to do limit as x approaches 1. And let's do x minus 3 over x plus 2 times x plus 1. Okay, so note, so the limit's going to 1, right? Note 1 is in the domain. This rational function, it looks like it has it's defined everywhere. It has domain over the whole real line except for -2 and -1. So 1, positive 1, is in the domain. So we can go ahead and use this fact above that we just stated. And all we got to do to figure out what this limit is just plug in 1 everywhere we see an x. So this would be 1 minus 3 over 1 plus 2, 1 plus 1. So that's going to be like what? -2 over 3 times 2. So it'll be, I think this applies to -1/3. Super straightforward. Some limits are a little bit trickier though. Some limits, it can be difficult to actually apply any of the fun facts or laws or special limits that we have defined so far. And sometimes when we come across a tricky limit like this, we need to do a little bit more work to it first before we can start calculating. So let's say we want to define the limit as x goes to 0 of 3 plus x squared minus 9 over 8. Okay, so note 0, so x going to 0, is not in the domain. Okay, and we also can't apply the limit law that said that if you have a function over a function, then you just split the limit up over the division. We can't do that because the limit as x goes to 0 of x is going to be 0. And we don't want to divide by 0. That'll break things. So we have to do some funky rearranging to this before we can go ahead and compute what the limit is. So to rearrange this, what I think I'm going to do first, I'm going to go ahead and expand out that 3 plus x squared. And maybe we might get something simpler. So we get, when we do that, you get 9 plus, I think this is going to be 6x plus x squared minus 9 over x. Okay, now I could see that these 9s cancel. So let's go ahead and cancel those out. We get limit as x goes to 0 of 6x plus x squared over x. Okay, now I see a common factor of x in the numerator. So what I'm going to do is I'm going to go ahead and pull that out from the numerator. So we get limit as x goes to 0 of x times 6 plus x all over x. And now here comes the magic. We can go ahead and cancel these two x's right there. Now we have the limit as x goes to 0 of 6 plus x. Aha! This is a much simpler limit. In fact, we can just split it up across the addition, or if we're being suave, we can notice that 6 plus x is technically a polynomial. So what we can do is we can just plug in 0 to it. So we get 6 plus 0, and that is equal to 6. So some limits are pretty straightforward, especially if they're rational or polynomial functions. Some of them can get a little trickier. Sometimes you need to use limit laws and some of the facts that we've talked about today. Limits are one of those things that's they're either really straightforward or incredibly complicated. I'm absolutely certain that if you were to just make up some limit on the spot and hand it to me and ask, hey, can you compute this? I might not be able to because limits can get really nasty really quick. But try not to let that scare you. The limits we'll be doing in this class are going to be fairly straightforward. And they will get more straightforward as you practice them more.